How does a loss function optimize CNN image classification? Imagine trying to teach a computer to recognize your favorite animals in pictures. How does it get better at telling a cat from a dog? That's where a loss function comes into play. It acts like a scorekeeper, telling the computer how far off its guesses are from the real labels. When a CNN, or convolutional neural network, makes a prediction, it produces a set of numbers called probabilities for each possible class. The loss function then calculates a number that shows how wrong or right those predictions are. The goal is to make this number as small as possible. This process is like a game where the CNN learns from its mistakes. An optimizer, such as Stochastic Gradient Descent or ATOM, uses the loss value to tweak the CNN's internal settings, called weights. These weights are like dials that control how the network processes images. By adjusting them slightly, the CNN gets better at recognizing patterns in images. This adjustment happens through a process called backpropagation, which figures out how each weight impacts the loss. Over many rounds of training, the CNN fine-tunes these weights to improve accuracy. Different loss functions are used depending on what kind of classification task is at hand. For example, if the task is to decide if an image is a cat or a dog, a binary cross-entropy loss is used. It compares the predicted probability with the actual label, which is either 0 or 1. For recognizing multiple classes, like digits from 0 to 9, categorical cross-entropy loss is common. It compares the predicted distribution over all classes with the true class label. There's also a variant called sparse categorical cross-entropy, which handles labels as integers instead of one-hot vectors, making it more efficient in some cases. Choosing the right loss function is key because it shapes what the CNN learns. It sets the target for the model to aim for during training. When combined with an optimizer, the loss function guides the CNN to improve its predictions step by step. This process is the backbone of how CNNs become better at classifying images. In real-world applications, this means more accurate image recognition in areas like medical imaging, content filtering, or even facial recognition. Understanding how a loss function works helps us see how AI models learn from data and get smarter over time. It also ensures that AI systems make fairer and more precise decisions, which is vital as these models become part of everyday life.